Hello everyone, I am Anisha Suman from Sapien Razorfish, presenting in front of you a very interesting and hot topic of machine learning, that is, why this is like short, that's GAN, that is Generative Adversarial Network. So my topic for today is the powerful tools for media generation GAN. Okay. Before I start, let me know how many of you have any idea about GAN. Show me your hands. Anyone know about GAN? What does it work? What it does? What it is? Anything about this? No. Okay. Okay. Don't worry. Then let me play a song for you. So, how was the song? Like, how many like this song? Whose favorite this is? Okay, your favorite. And others?
We like it just.
Okay. Now tell me, who was the person that came into your mind when you were listening to this song? Amitabh Bachchan? Okay.
My wife.
Okay. That's good. So, like majority can say Amitabh Bachchan?
Yes.
Okay. Now, let me play this song again for you. So, who was the singer? Suresh Bhosle. Okay. Like, you must be wondering why I played that song and like why I played it again.
Voice recognition.
Test data.
Sorry?
You're generating test data of that.
A little bit. Any idea? Okay. Things will get clear with GAN, but before proceeding to GAN, let's have a quick view of my agenda for today. It's like, it's written. So, what is GAN? As you can see, this is the GAN model that consists of training sample data, that is like these are some images, and it has two agents. First one is G, generator, second one is D, that is discriminator. So what G does, it takes some random numbers, any numbers, some random numbers as an input, and it tries to produce images that look similar to training sample images. Am I clear? And what discriminator does, it takes an image as an input and it tries to identify whether the image is real or fake. That is, images from training sample data, that is real, or images from generated sample data, that is fake. Now, consider a real life situation where there are two persons. First one is police inspector and second one is criminal. So, what criminal is doing? She does money forgery by generating the fake money. And what police inspector does? She has to identify, she has to distinguish whether the money is fake or money is real. Now you tell me, between generator and discriminator, who is acting as a criminal and who is acting as a police inspector? What? Okay, understood. G is criminal and D is police inspector. Okay, now move back to the song example. Like what was happening there? Sudesh Bhosle, he was the generator. He was trying to mimic the voice of Amitabh Bachchan, and you guys were discriminator who were trying to identify whether the person was Amitabh Bachchan or the person was Sudesh Bhosle by listening the song. Now you are clear like why I played that song and why I played it again with video. Things are clear? Good. Next one. How does GAN work? Can you see the slide clearly? Like, can you read it clearly? Okay. Then before I start, I want you to go through the slide for a moment. Like this is the function of discriminator from bottom to up. And this is the function of generator, that one is from bottom to up. So like let's take a moment, read through it and like try to understand what is depicting. Are you getting the function, like what it is doing? No? Anyone? Okay, leave the slide. Forget this slide. Just think about, just go back to the example of criminal and the police inspector that I was talking. So what was happening there? Let's suppose police inspector, she is able to identify real money and fake money. So what she does, like if she identifies money as real money, she labels it as real money, and if she identifies money as fake money, she labels it as fake money. Okay. Now if she is easily identifying police inspector, she is easily can distinguish these two money. It is becoming difficult for criminal because like police inspector can easily distinguish. So what criminal does? She improves herself so that she can produce the money, she can produce fake money that will look similar to real money. And since criminal is improving herself, so now what is happening? It is becoming difficult for police inspector, as like now she has to work out hard, she has to prove herself, so it will be easy for her to distinguish between these two money. Clear? Am I clear? Like this is a very real life scenario. Okay. On the same principle, GAN, our criminal, and discriminator, our police work. So what happens? Generator, it generates images so that it can fool the discriminator, and discriminator will mistakenly label those generated data, those fake images as real data. That is, it can label them as real training sample data. Things are clear, like how does GAN work? Cool. Yeah, my next topic is convolutional neural network. Again, how many of you know about convolutional neural network? Okay, good. And like there are many people who don't know about, so I want to go through it. Okay, again leave this slide. Go back to your childhood memories and think about your 5 friends with whom you would love to play. Okay, just close your eyes and imagine you are playing with them. Okay, so keep your 4 friends with you and stand in a queue. Keep yourself at the first position and keep your 5th friend away from the queue. Okay, it's like your 4 friends and you are standing in a queue, and your 5th man, he is away from the queue. Now what you are doing, you look at an image, try to analyze what has been given here, and then you tell it to second person. Okay, now what second person will do, what she has listened so far, she will tell it to the third person, but again in smaller description. Okay, and things go on like this. So what happens, your fourth friend, who is the last person in the queue, she will have the smallest description about image. Clear? Now what she will do, she will go to your fifth friend and give her the exact description what she had. Okay, and then your fifth friend, she should be able to identify, she should be able to classify the image based on what the information she has. Like she has to identify from the collection of images the image you were describing. Okay, like you all understood the rule of GAN. What are the rules? Same thing happens in CNN. Consider yourself and your friends who were standing in the queue as a layer. In this what happens, convolutional neural network, it basically works for images, for classification of images, which takes image as a 3D input. By passing through a layer, it generates a 3D output, that is 3-dimensional matrix output. So what happens, when passing through a layer, a filter is being applied on the image. Like let's suppose this is an image, this is a 3-dimensional matrix. Filter, everyone know what a filter does. Like it separates out useful information from less useful information and allow the more useful information to pass through the layer. Okay, so same thing happens here. As in like this is a 3-dimensional matrix input, that is an image. Filter it is a small window, as you can see. Like it is a window that slides all over the images like this and extracts the useful information from that part of the image. And what they do, like those extracted information, they make the another 3D output. So same thing happens here. Like there is a you can see there is an image of size 45 into 45 into 3. A filter is being applied of size 6 into 6, and then it is giving a 3D output. And passing through each and every layer, like passing through the layers, it is giving at the last a 3-dimensional output of size 4 into 4 into 128, that is being converted into a 2D matrix. So this the matrix, the 3-dimensional matrix 4 into 4 into 128, it has the smallest description about the image and the most information, most useful information about the image. Okay, things are clear. So now you tell me, like why I was talking about CNN. I was talking about GAN, generator, discriminator, police inspector, criminal. Then I moved to CNN. Any thought about it? Like those who know about CNN? Idea?
The CNN will be applied to identify that original image. Logical CNN will be applied.
Yeah, that's correct. But there is one more use of this architecture that will get clear in our next slide. So my next slide is about various GAN architectures. Okay. Yes, first architecture is deep convolutional GAN, that is DC GAN. And like what you can see in this image, tell me.
It's other way around from the CNN, like CNN was from bigger image to the smaller ones. This is from smaller to bigger.
Yeah, that's correct. As in like you can see CNN network, but in reverse manner. Like there was a image, then it was getting smaller in size, but there is a, like you can see pretty clear what is it. It consists of a 2D matrix that is being converted into a 3D matrix, and when a filter is applying, it is getting increasing in size, and at the end, in this example only, like we are getting an output of size 64 into 64 into 3, that is an image by the generator. So generator is taking a random noise, at the end it is producing an image. Okay. Now tell me here what you can see. I mean in context of CNN. Again a CNN architecture, right? The CNN architecture that I showed you earlier. Yes. So this is the network of discriminator that takes an image as an input of size 64 into 64 into 3, passing through each layer. It is applying a filter of size 5 into 5, and like it is getting smaller in size. At the end, it is giving an output of size 4 into 4 into 512, which is at last giving a 2D matrix that contains the probability, that contains the value that tells how much this image belong to training sample data or from generated sample data. Clear what a discriminator is doing here and its architecture? Great. Now this is an application of DC GAN, that is phase generation. Like when the GAN model was being trained, these were the images that were being generated by generator. Okay, and here you can see the, like after a few iterations what is happening, then after a few iterations what is happening. That's it. Okay, just 1 minute. I will get it back later. Okay. And like these are again the images of phase generation after few iterations. Like you can compare these 4 images and can understand what is happening, what a generator is doing. Yes. Next architecture is about conditional GAN. As in from its name, it's pretty much clear like what may happen here. Like you have to generate something, but there is a condition. Now you tell me, any of you, what is an application of conditional GAN, either in the context of phase generation example or in any example, any application of conditional GAN? Sorry? Lighting. That was I'm asking. Like you have to generate something, but there is a condition. So this is the example I am looking for. Yeah. Like there is a cool example, like generating female faces, but with a mustache. Okay. So this is the conditional GAN, as in like you can see the generator. It is taking some random numbers as an input and giving and taking y, that is the condition, along with as an input and generating an image. What discriminator is doing, it is taking image as an input and trying to find the probability of that image based on given condition. Next application is conditional GAN. Again, these images are pretty much clear, like what it is doing. Generating digits from 0 to 9, it is generating digit only 7. Like, okay? Yes, they are these are very cool applications of GAN. Like it has already made its places in business sector. It is used to generate, it is used to visualize different industrial and interior designs. As you can see, it is being used to generate bedroom images. Okay, these bedroom images were not given as training data, but these were being generated by the generator. Now tell, how many of you pursue any hobby? Raise your hands. No hobby. And how many of you pursue painting as your hobby? Painting. Great. So for painters, it's a very interesting application. It's a very interesting tool. Like when you will draw something, GAN system will try to complete those images. Like if fashion designers, they use this tool. And like they use the system which is being trained on generating dresses, images of dress, and when they draw something, it tries to generate image of a dress based on what they have drawn. Next is face completion. As in this model was trained to generate human faces, and when incomplete human faces were given, you can see the output, what is happening. Now tell me, how many of you have have filed a complaint against a thief? No complaint against a thief. Okay. Okay, just imagine a condition where you are going to file a complaint against a thief. So what you do? First you go to police station, right? And then after what you do? Like you give a description about him, like how does he look? So GAN system, which is being trained on generating human faces, when you give those description, it will try to generate images of human face based on what condition you have given. Next is text to image generation. As in what is happening here, a text has been given as an input and generator tries to generate images based on given condition, right? So this is an interesting application because generator has to generate the images, but it has to generate images based on text, given text. And for discriminator, other than distinguishing the images, it has to identify whether the image is correct or not based on given text. Another application is video generation, and like you are giving image as an input and you are generating a video, predicting the video for next 1 or 2 seconds. So let's see a video related to this.
Creating a GIF. Creating a GIF. GIF. Creating a GIF.
So let's suppose like you are training a GAN system to generate longer videos. Like, isn't it very cool? Like, you can generate a whole movie based on given image. Like, I'm sure it's going to be a pretty big hit in film industry. Now let's move to developer section. So how many of you are C++ developer? Okay, and how many of you like Python? Okay. So if you are a C++ developer, you can use the Torch framework to start with GAN coding. And if you are a Python developer, you can use TensorFlow and PyTorch as your framework. Next is GAN online resources. As like we all know, Google is the place where we can search for anything. So Google is the answer. But still there are some links which are very good about GAN. So I want to recommend you. Like first one is video by Ian Goodfellow. He is the developer of this GAN model. Next two are related to architecture of GAN. Next one is again a video which gives a mathematical description about GAN. And the last one is a Stanford course of CNN. Okay. It's okay. Okay. And like while I was while I was giving the demo, I was training a model. Like here you can see epoch, D loss, like how discriminator has lost, and how much time it was wrong identifying the images, and like how it is G loss, like how much time discriminator was correct in identifying the generated image. And these are the images were generated. This is the first image and this is the last image right now in 15 minutes of training, and you can see still some difference. Like it will, when it will get trained from 1 hour, so then after it will generate some clear images, but still you can see at the first like 7 and then 7. So it is trying to generate digits from 0 to 9, but like I'm just telling you that see the difference, as in like it was it was being trained just for 10-15 minutes, so it has not improved that itself that much. Okay, so that's all from my side. Any question from me? Yeah.
So we have a accuracy level.
Yeah.
So what are the typical accuracy improvements applying this kind?
Typical?
Accuracy improvement, I mean, let's say 2% improvement, 3% improvement. Are there any, in your use cases, what are the typical, just plain comments? Let's say you got 70% accuracy, and you applied GAN, generated data, and is it improving? How much is it improving?
Sorry, I didn't understand your question very well, like what you were trying to say.
Take that one.
I
take that one.
Yeah, sure.
Text to image generation is only text you are giving or a sentence?
It may take a sentence, but that should contain the description.
While training, you read the text and the image corresponding to it, otherwise.
Sorry, are you asking a
Put it
question?
into some
Okay.
category typing. Otherwise, it will not know. Like if I keep on entering 7, it will not know that it was 7.